Iceland is making a desperate gamble, and if it fails, a part of the country simply ceases to exist. Right now, on July 4th, 2026, the ground on the Reykjanes Peninsula is quiet. There is no lava, no fire, no ash clouds grounding Europe's airplanes. To a tourist, it looks like peace. But what you're looking at is a geological lie. And it's a lie that's about to break. Let me know in the comments if you think engineering can actually stop a volcano. Beneath the surface, something is happening that has never been recorded in this volcanic cycle before. A magma chamber is swelling to a critical mass, not slowly. Relentlessly, a staggering 27.5 million cubic meters of molten rock has accumulated just kilometers beneath a critical power plant, inflating the ground at a steady 2 centimeters every single month. This isn't the end of an eruption. This is the prelude to a much larger one. This is a system loading a bigger weapon, not a maybe, a win. This is a story that is unfolding right now, and most people don't understand the real stakes. A huge number of you who watch these reports forget to subscribe. If you want to understand what happens next, you need to hit that button. It's the only way to stay ahead of it. For the scientists at the Icelandic Meteorological Office, the silence is the most terrifying sound in the world. They watch the GPS stations, they measure the ground deformation, they analyze the gas emissions, and every single data point tells them the same story. The system has reached its tolerance limit. The stress is becoming unbearable. Kristen Genstier, the head of the IMO's Natural Hazards Department, put it in the starkest possible terms. A new eruption is simply getting closer. More magma, she warned, could mean a larger eruption. The official hazard assessment, just extended through September 2026, contains a number that should stop you cold. 20 minutes. That is the shortest possible warning the IMO expects before the ground could split open. 20 minutes from the first definitive signal to a new fissure tearing through the earth. Imagine working at the Svartsengi power plant, knowing that at any moment an alarm could sound, and you have less time than a lunch break to escape before your workplace is engulfed by one. 100 degrees Celsius lava. This isn't a theoretical risk. It is a constant, suffocating state of emergency. Infrastructure workers live with evacuation drills and the permanent knowledge that the ground beneath their feet is not solid. It is the bulging skin of a subterranean monster. So, the real question is, how did Iceland get here? How did it go from celebrating a spectacular tourist volcano to holding its breath on the edge of a potential catastrophe? The story begins on March 19, 2021. After 800 years of complete silence, the Reykjanes Peninsula woke up. A fissure opened in a remote valley near a mountain named Fagradalsfjall. The eruption was beautiful. Effusive, the lava flowed like a glowing, syrupy river, building new land, creating spectacular cones of black basalt. It was geologically fascinating, and crucially, it was safe. It threatened no towns, no infrastructure. The world watched, mesmerized. It became a global tourist attraction. Hikers trekked for miles to witness the birth of New Earth. It was nature's greatest show, a seemingly benign spectacle that put Iceland's volcanic heart on full display. A second eruption followed in 2022, and a third in 2023, all in the same general area. They were fiery, dramatic, and ultimately manageable. The world got used to seeing videos of Icelandic volcanoes. It felt normal. It was a spectacle, a tourist's dream. Looking back now, it feels like a warning everyone missed. What's the most powerful force of nature you've ever witnessed? Tell us below. For nearly 3 years, the fires of Reykjanes were a chapter in a geology textbook, come to life. Iceland had a new volcano, and it knew how to handle it. The eruptions would start, put on a show for a few weeks or months, and then stop. The system would vent its pressure, and a quiet equilibrium would return. It was a predictable cycle. It was a containable phenomenon. Until it wasn't. In late 2023, something fundamental changed deep within the Earth's crust. The plumbing system shifted. The magma stopped rising beneath the empty valleys of Fagradalsfjall and began forcing its way upward miles to the west, directly underneath the Svartsengi geothermal area. This was not just a change in location. It was a catastrophic escalation of the threat. Suddenly, the volcano was no longer a distant spectacle. It was now directly beneath the Svartsengi power plant, the facility operated by HS Orca that provides electricity and essential hot water to the entire peninsula. It was beneath the Blue Lagoon, Iceland's most famous tourist destination. And it was just to the north of Grindavík, a fishing town of roughly 3,000 people. The monster had moved from the wilderness to the city gates. This is the moment the problem changed, when the fire moved from a remote valley to the backyards of a sleeping town. If you find this story important, hit the like button and share this with your family. Understanding this is more critical than it seems. Grindavík had existed for centuries, a community built on the fishing trade. Its identity tied to the cold, rich waters of the North Atlantic. Its residents had lived with earthquakes and the vague knowledge of the region's volcanic past, but never in living memory had they faced a direct threat. In November 2023, that changed. A swarm of intense earthquakes signaled a massive intrusion of magma snaking its way beneath the town itself. The Department of Civil Protection and Emergency Management ordered a full evacuation. The entire population was forced to flee, leaving their homes, their businesses, their lives behind. What happened next was not a simple lava flow. It was something more insidious. The ground itself began to fail. Giant cracks and fissures, some of them dozens of feet deep, tore through streets, gardens, and the foundations of houses. The town was being ripped apart from below. Geologists realized the magma wasn't just flowing, it was creating a massive vertical sheet, a dike, that was physically breaking the crust. Grindavík was being sacrificed, split in two by a force that no wall could stop. Then, on December 18th, 2023, the first eruption of this new, terrifying phase began. A massive fissure opened in the Sunkur crater row north of the town. The sky turned orange. The display was terrifyingly beautiful, a wall of fire on the horizon. But this was just the beginning. The system was now primed, and on January 14, 2024, the worst fears of every resident and every scientist were realized. A new fissure opened right on the edge of town. A smaller, secondary crack appeared inside the hastily built defensive barriers, and lava began to pour directly into Grindavík. It was slow-moving, but utterly unstoppable. It crept into residential streets, engulfing everything in its path. News cameras captured the surreal, heartbreaking image of houses catching fire, their roofs collapsing as molten rock consumed them. A town that had stood for generations was being erased in a matter of hours. This was a new kind of eruption. It was personal. It was destructive. The tourist volcano was dead. In its place was a relentless geological siege. Between December 2023 and the summer of 2025, the Sunkur system would erupt 9 separate times. Each time the cycle was the same: weeks of magma accumulation, rising ground, intense earthquake swarms, and then a violent release. Sometimes the lava flowed for weeks, sometimes just for hours, but each time it left the region more scarred, more fragile, and the threat level permanently higher. The town of Grindavík was deemed unsafe for habitation. Its people became permanent evacuees, scattered across Iceland, their futures uncertain. The town became a ghost town, a ruin bisected by deep chasms, its northernmost houses blackened by cooling lava, a monument to a battle that humanity had lost. But Iceland was not prepared to sacrifice its most critical infrastructure. The fight for Grindavík was lost, but the war for Svartsengi was just beginning. The plan was audacious. It was desperate. The engineers and civil protection authorities had a single, seemingly impossible objective: stop a river of molten rock. The Svartsengi power plant and the Blue Lagoon could not be evacuated. They represented billions of dollars in infrastructure and provided the lifeblood of the entire Reykjanes region. If the power plant went down, thousands of homes would lose heat and hot water in the middle of an Icelandic winter. The stakes were absolute. So, they fought the volcano with bulldozers. In a frantic, round-the-clock operation, construction crews began moving mountains of earth and rock. They drove heavy machinery onto the volcanic plains, often with the ground shaking beneath them and the threat of a new fissure opening at any moment. Their goal was to build massive earthen barriers, giant berms designed to redirect potential lava flows away from the power plant and the spa. It was a primal, almost medieval strategy. Building a wall to hold back a monster, except the monster was 2,000-degree liquid rock. The engineering was brilliant. The execution was desperate. They studied topographic maps, modeling how lava would flow across the landscape. They identified the most likely paths from the Sundenkur crater row and built diversions. The walls were not simple mounds of dirt. They were carefully engineered structures, dozens of feet high, packed and reinforced to withstand the immense heat and pressure of a lava flow. During the eruptions of early 2024 and 2025, these walls were put to the ultimate test. Fissures opened, and lava poured forth, heading directly for the power plant. The world watched live drone footage as the glowing orange tide hit the dark earth of the man-made barriers. The lava pooled, it diverted, it flowed along the channels the engineers had created. It worked. The walls held. A fleet of bulldozers and a team of determined engineers had successfully steered the destructive power of a volcanic eruption. And if you're finding this deep dive valuable, I know, I'm asking again, but please take 1 second and subscribe. It tells the algorithm that these detailed stories matter, otherwise they just get buried. It's incredibly important for the channel. The successful defense of Svartsengi was a major victory. It was a testament to Icelandic ingenuity and grit. But here's the part they don't celebrate. The walls can only redirect what comes to the surface. They cannot stop the pressure building below. The eruptions that were diverted were relatively small, short-lived events. The magma chamber that fed them would seal up, and the process would start over. But each time, the amount of magma that stayed in the ground grew. The system was not fully emptying itself. It was accumulating a surplus. And that brings us to today, July 4th, 2026. The last surface eruption ended on August 5th, 2025. For nearly a year, there has been an unsettling quiet. But this quiet is not peace. It is pressure. The 5 million cubic meters of magma now stored beneath Svartsengi is the largest volume ever detected between eruptions in this entire 5-year cycle. It is a staggering amount of molten material. How much is it really? It's enough to fill 11,000 Olympic-sized swimming pools. It's more than the total volume erupted in several of the previous events combined. It is, as one University of Iceland geophysicist, Magnus Tumi Guðmundsson, has noted in his flight assessments, a sign that the next event will be on a different scale. The ground itself is telling this story. The constant uplift, measured at 2 centimeters per month, is the physical manifestation of this growing pressure. The land is being forced upwards like a slowly inflating balloon. Since the magma intrusions began in earnest in November 2023, the ground at Svartsengi has risen by a full meter. The strain on the rock is immense. It is a physical system approaching its breaking point. And just today, a magnitude 4.7 earthquake struck on the Reykjanes ridge just offshore. A sharp, violent reminder that the entire tectonic plate boundary is alive and violently restless. The system is not sleeping. It is priming the cannon for a much larger shot. This entire crisis is happening at one of the most geologically significant places on the planet. The Reykjanes Peninsula is not just a piece of Iceland. It is the physical boundary where the North American and Eurasian tectonic plates are actively pulling apart. This is a divergent plate boundary, a place where the Earth's crust is thin and magma has a relatively easy path to the surface. For 800 years, that process was slow, deep, and largely invisible. But in 2021, something changed in the mantle below, and the system woke up. The science being deployed to understand this awakening is extraordinary. An array of seismometers, GPS units, and gas sniffers blankets the peninsula. Satellites from space use radar to map ground deformation with millimeter accuracy. Iceland has become the world's foremost natural laboratory for volcanism. Specialists like Michelle Parks at the IMO, who was recently elected to chair a global geohazard initiative, are at the forefront of this effort. They are pioneering techniques to read the volcano's vital signs in real time. They can model how much magma is flowing in, where it's being stored, and how the crust is responding. Orvaldur Rarsson, a professor of volcanology, provides crucial analysis on the big picture. He and his colleagues at the University of Iceland have framed this not as a series of isolated eruptions, but as a single, continuing event. A new volcanic epoch for the peninsula that could last for decades, or even centuries. This is the new normal. The cycle we are now in, long periods of quiet inflation followed by a rapid, violent fissure eruption, is the pattern they expect to continue. The pressure cooker builds steam for months, then violently releases it, only to seal up and start building again. The problem is that the pressure cooker is getting bigger, and the next release is expected to be proportional to the pressure that is built up. The 27.5 million cubic meters of magma isn't just a number, it's a threat, and it forces an unsettling question. The defensive walls were built to handle the flow rates of the 2024 and 2025 eruptions. Can they handle a flow rate that is potentially double or triple that size? What if the next fissure opens in a different location, one the walls were not designed to protect? Valentin Troll, a volcanologist from Uppsala University, stated the situation plainly earlier this year. Iceland is probably going to erupt again very soon. It's a consensus shared by every scientist watching the data. The inevitability hangs over the peninsula. One of the few pieces of good news in this entire saga is what is not happening. Unlike the 2010 eruption of Eyjafjallajökull, these eruptions do not produce the massive ash clouds that paralyze air travel. Eyjafjallajökull is a stratovolcano capped by a glacier. When its magma erupted, it instantly interacted with ice, creating an explosive burst of fine ash that was propelled high into the jet stream. The eruptions on Reykjanes are different. They are effusive fissure eruptions. Liquid lava flows from cracks in the ground. There is no ice, and the interaction with groundwater is minimal. This means they produce localized lava flows and toxic gases like sulfur dioxide, but not the high-altitude ash that threatens jet engines. Keflavik International Airport, Iceland's main hub, has remained fully operational throughout this entire crisis. Tourists are still arriving. Life, for most of Iceland, goes on. But on the peninsula itself, life has been fractured into two realities. The reality for those living on top of the volcano, and the reality for everyone else. And what about the town of Grindavík? Its fate remains the most tragic and unresolved part of this story. For now, it is a ghost town, a Pompeii in slow motion. A few residents hold out hope that they might one day return, but the scientific consensus is grim. The ground beneath the town is fundamentally unstable. The risk of new fissures and further subsidence is simply too high. The town that was sacrificed to the volcano may never be reclaimed. Its empty houses and cracked streets serve as a permanent, chilling reminder of the power simmering just beneath the surface. It is a geological wound that may never heal. The community has been shattered, its 3,000 residents now scattered, their lives irrevocably altered. They are the human cost of a geological awakening. The defensive barriers at Svartsengi represent an incredible feat of engineering and human resolve. They are a symbol of Iceland's refusal to simply surrender its critical infrastructure. That defiant stand against the volcano is inspiring. It is a story of humanity pushing back against an elemental force. But the volcano has not been defeated. It has been merely inconvenienced. The 5 million cubic meters of magma gathering below is not aimed at the walls. It is aimed at the path of least resistance. And the one unchanging law of geology is that it will always find one. The work of the IMO, of the university scientists, of the Civil Protection Agency, is now a race against physics. They are trying to predict the unpredictable, to give those 20 minutes of warning, to save lives when the ground finally gives way. The entire situation is a paradox. A country with some of the most advanced volcanic monitoring on Earth is still fundamentally at the mercy of a force it cannot control. They can watch the monster wake up, they can track its every move, they can even build walls to try and steer it, but they cannot put it back to sleep. The 800-year dormant period is over. This is the new reality, a state of permanent vigilance. As we speak, the ground in Svartsengi is rising, the pressure is building, the system is moving toward its next failure point. The silence on the peninsula is not an absence of activity, it is the sound of a countdown. The engineering has worked. The science has been extraordinary. The monitoring is second to none. And none of it may be enough. The earthen walls built to save the power plant were designed for the eruptions of the past. They are being tested now, in this moment of quiet tension, against the eruption of the future. The one that is still building, invisibly, relentlessly, deep underground. The geological models point downward. The magma volume points upward. Somewhere in the middle, the people on the Reykjanes Peninsula wait. They know the next time is coming. What Iceland has built is the most advanced, expensive, and desperate geological delay tactic in human history. A system of monitoring and defense to buy time against a force that operates on a scale that dwarfs human intervention. Was it a solution? Or was it just the bravest possible way to stall the inevitable? The tunnel of lava is building. The ground still swells. And somewhere beneath the